Hi, this is lecture 3 for week 4 of CS 1030. And in this piece, we're going to talk about a new sorting algorithm called insertion sort, and this is going to complement the selection sort that we already talked about. So let's talk about insertion sort. So insertion sort, in contrast with selection sort, is a little bit more intuitive in the sense that it's a little bit more like, or at least probably a little bit more like what you would do if you had to sort a pile of papers. So let's pretend that I gave you a pile of papers and you need to alphabetize it. So if you wanted to execute the insertion sort algorithm yourself, what you would do is take the top item off take the top piece of paper off the pile, and then you would put it into a sorted pile of papers in the correct place. So what this means is you're always pulling something off the top of the unsorted list, and then you have to go to the sorted list and kind of flip through it to find the correct place to put it. And so what you do is you basically compare it to each item in the sorted list until you find the two that sort of surround it, and then that's where you insert the new item to the list. And so if you remember, the selection sort scanned the unsorted list, but then it had an easy job on the sorted side. This puts the work the other way around. We have an easy job pulling things off the unsorted list because we just take the top every time, but now we have to scan the sorted list. And it's sort of 6 of one, half dozen of the other. It's basically ends up being roughly the same amount of work, but it's a distinct algorithm that has advantages at certain times. So insertion sort is an easy algorithm. It just means put things in the correct pile in the correct place in the sorted pile. And so let's go through it in a little bit more detail. So here we've been given an unsorted list. It contains 5 items. So this is a scratch list or a list in whatever other programming language you might be looking at. And the initial condition is we have this list that's unsorted, and we're starting with a sorted list that's empty. So let's look at the algorithm. So the way it works is we pull the first item off the unsorted list, so it's 5. Then the question is where to put it in the sorted list. Well, the sorted list is empty, so it doesn't matter where we put it. But just to be consistent, we're going to say we're going to insert it after the front. So the front element of the sorted list is sort of an imaginary 0th place in the list. It's kind of the placeholder for something at the beginning. So if we insert something after the front, it becomes the new front of the list. So the sorted list now contains 5. But again, of course, it didn't matter where we put it because there was only one place. Okay, so that was the first iteration of insertion sort, the first iteration of the outer loop of insertion sort. And so let's go to the second iteration of the outer loop. So now we have 4 items unsorted left to sort. We pull the first one off. It contains the value 2. And the question is, where are we going to insert it? And now this time it matters where we put it. If we put it after the 5, we'll get an unsorted list, so that's clearly broken. So what we have to do is put it after the front of the list again. The 2 becomes the new front element of the list, and we get 2 and 5 on the sorted side. And something we have to be absolutely sure of is that the sorted list is always sorted at every step of the way. If it's ever not, then our algorithm is broken because there's no part of the insertion sort that goes and fixes the sorted list. The sorted list has to be sorted at all steps, or else we just have something buggy that sucks. Okay, so let's go to the third iteration of the outer loop of insertion sort. So we have 3 things left. We pull off the first one, which is 1. Where do we insert it? Well, there's a process that we have to go through where we scan the list. So now we'll look at the previous list. And what we do is we look at the first item in the list, and as soon as we find an item that's, as soon as the item that we're inserting, as soon as we find the correct place for it, then we know where to put it. We do that by sequentially comparing the new item with each item in the sorted list. So the new element again goes in the front. So now we have 1, 2, 5 on the sorted side. So in the 4th iteration of the outer loop, we pull the first element off the unsorted list, which is now 4. Now the question is where to put this. Where do we insert it after? And again, the question is what 2 elements does it fit between? And we do that using the comparison operator that we were given. And it goes between the 2 and the 5. So we insert it after the 2, and we keep a sorted list. So finally, we grab 3 off the unsorted list, which is now done. It's empty. And so we have the value 3, and the question is where to insert it. And again, it goes after the 2. So now we end up with a sorted list with 1, 2, 3, 4, 5. And in the final execution of the outer loop, we're just going to notice, we're not going to actually do anything here. We're just going to notice that the unsorted list is empty. And that's going to be the termination condition for the outer loop of the insertion sort. So in the end, we have to be left with an empty unsorted list. And the sorted list has to contain not only the same exact items that had been in the unsorted list earlier, but they also have to be in order. And remember that those are the 2 correctness criteria for a sorting algorithm. Okay, so in this piece, we're not going to look at pseudocode or actual code for insertion sort. We're just going through it at this level of detail. But one thing I want to show you before we finish is, here's an item that I bought. So I actually have one of these because I ordered one because I thought it was cool. And when I lecture in person, I bring this in to show people. But this is a sorter. This is a physical sort of manifestation of insertion sort. So this is what people in kind of old-timey offices before electronic automation would use to sort pieces of mail or whatever by recipient. And so what you would do is you would take up unsorted pile of mail, and then each time you do that, you find where it goes in the sorted list and just tuck the envelope in between the two tabs that determine the place where it goes. So basically, all I wanted to show you is that this is a sort of a physical manifestation of the insertion sort. It's a useful algorithm for people, and it's also useful for computers. Thank you.